everyone, welcome to the new video. Here we are going to see the conic sections under the engineering graphics. So what do you mean by conic sections? We can actually define it as the conic sections can be obtained by the intersection of a right circular cone by a plane in different positions relative to the axis of the cone. Here you can see from the diagram that is the plane given in blue color is intersecting the cone in different angles to get different shapes. Here we can call those shapes as parabola, circle, ellipse and hyperbola. So you can see here in this slide, you can see the concept, that is the definition of different curves. When you cut a cone perpendicular to its axis, then you will get a circular section. So if the cutting section is inclined to its axis and cuts both the generators, that is, you can see from the figure, that is a second figure, you can see the front view of the cone, which looks like a triangle. Okay, so those two lines which are inclined to the axis are called the generators. So generating lines, or otherwise we can say like that, if the cutting section is inclined to its axis and cut both the generators, you will get the ellipse. In case of parabola, the section plane is inclined to the cone axis and parallel to one of the generator line, as you can see in the third figure. Finally, in the case of hyperbola, which is classified as a normal and a rectangular hyperbola, where which the section plane makes an angle smaller than the angle made by the generator to get normal hyperbola, and if the cutting plane is parallel to the cone axis, then we will get the rectangular hyperbola as mentioned in the figure 5. Okay, now you can also define the conics. That is, in another way we can define the conics as the locus of points or collection of points moving in a two-dimensional plane in such a way that the ratio of its distance from a fixed point and a fixed straight line is always a constant. So for understanding this concept, you need to know about the focus, directrix, eccentricity, vertex and minor and major axis. So here the focus is a fixed point about which the conic section is constructed. That is, focus is similar to the center of the circle, about which the circle is constructed about the center. Okay, so precisely saying, in the case of circle, which is also a conic section, center and focus of the circle are exactly the same point. Center and focus, both of them are the same point. Okay, but in the case of other conic sections, the focus and center of the curve are at different collinear points. That is, focus is away from the center, which is why we have to learn about the concept of eccentricity. So for understanding the concept of eccentricity, we use an imaginary fixed line constructed away from the curve, which is called as the directrix. So we can define the eccentricity as the shortest distance of the moving point on the curve, or arbitrary point or random point, from the focus to the shortest distance from the directrix. So here you can see different curves, ellipse, parabola, hyperbola, in the figure. So in the case of ellipse, the moving point or arbitrary point is constructed as point P. Then the eccentricity is Pf by Pm, and in the case of ellipse, the eccentricity is always less than 1. In the case of parabola, the eccentricity, that is here qf by qn is equal to 1, and for hyperbola it is rf by rs is greater than 1. So that is called the eccentricity. Now we are going to see here in this section, we are going to see the concept of ellipse. That means how to draw ellipse by means of different methods. Before that, we should know ellipse has major and minor axes, 2 foci and 2 vertices. You can see those mentioned in the figure. Here AB is the major axis and CD is the minor axis. A and B are 2 points of vertices, and you can see the distance from the focus to the point C is equal to the half major axis, half of the major axis AB, that is AB by 2. Okay, now we should know different methods to construct the ellipse. There are different kinds of methods to construct, like concentric circle method, rectangular method or oblong method, arc or circle method or foci method, trammel method, four centers method, and also eccentricity method. Now among which we are going to see concentric circle method, rectangular method, and eccentricity method. So we can see that concept here. So here we are going to see the ellipse by means of concentric circle method. A question is given: a flower bed in a botanical garden is in elliptical shape with major and minor axis dimensions are 9 meter and 6 meter respectively. Draw the profile of the flower bed by concentric circle method. Here the given dimensions are 9 meter and 6 meter respectively. So these dimensions are actually very big, and we cannot draw these dimensions in a normal drawing sheet. So we have to convert it into the convenient form, convenient dimensions by means of scaling. So here 1 meter is 1000 mm, we know that, and while we use 1:100 scaling, let's say, so then 1000 mm becomes 1:100 is 1 by 100, so 1000 becomes 10 mm, and 9 meter is 9000 mm, so 9000 mm becomes 90 mm, 6000 or 6 meter becomes 60 mm. So we use the scale of 1:100. For that, we have to draw two concentric circles having diameters 90 mm and 60 mm. So 90 mm in the sense 45 mm radius, so 45 mm radius, and 60 in the sense 30 mm radius. So after drawing this, we have to divide these two circles into 12 equal parts. So the angle of one complete circle is 360 degree. So while dividing into 12 equal parts, 360 divided by 12 gives 30. So we have to draw divisions in 30 degree line. So here the circle is divided into 12 equal parts, and after that we can name each and every points on the circle. So let's say it is 1, 2, 3, 4, 5, 6, 7 up to 12, and here at this point we have 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 up to 12 dash. So after that we can connect 1 dash, 1 and 1 dash by means of straight lines like this. From 1, draw vertical downwards vertical line, and from 1 dash we can draw horizontal line like this. Okay, so from 2 dash a horizontal line like this, and from 2 a vertical line. So similarly we have to draw lines. So after that we have to draw lines like this. So then we will get points, different points at this corner. So then we can draw ellipse by means of hand drawing. That's starting from 12 we can connect these corner points to draw the required ellipse. Then here finally we will get a figure like this. The curve which is drawn in the yellow color here is called the ellipse, and after completing we can mark the points, these corner points, as P1, P2, then here it is P3 and P4, P5 up to P12. Okay, so if you want to mark the focus point on the ellipse, then you have to use the relationship like the half major axis, that is O12 or OP12. So that will be equal to the distance P3 F1. So the half major axis distance will be equal to the distance from the point P3 to the focus. So then you have to measure the distance O12 distance, and then by using compass you can mark that distance here from P3 to F1. Just have to draw an arc which is having a center of P3 and radius of O12 on this line. Then we will get F1. Similarly we will get F2, the second focus. So we will get the focus F1 and F2. Okay, now we are going to see another problem, similar problem. Here the question is, the foci of an ellipse are 80 mm apart and the minor axis is 60 mm. Draw the ellipse by concentric circle method. Also draw a tangent and normal to the ellipse at a point 20 mm from the major axis. So we have to construct the ellipse here, and also we have to draw the tangent and normal. Tangent means it is a straight line which passes through only one point of the curve. So here the foci of an ellipse are 80 mm apart. So here we have to plot the two focuses which is 80 mm apart. So after that, here in the question it is given that the minor axis is 60 mm. So we have to draw a circle of diameter 60, or otherwise the radius is equal to 30 mm at the midpoint of this line. So after that we have to draw vertical lines like this at the center of the circle. So after that we have to measure the distance from this point, that is this point, to the focus. Here it will be around 50 mm. So the same 50 mm distance we have to take it from the center. Here this is the center, so we have to take same 50 mm, so it will go beyond the focus, 50 mm on both sides. Then we will get 2 points here, this point and this point. These 2 points are the vertices of the ellipse. Okay, that's how we have to plot the vertices and foci. Initially we have to draw, or we have to plot the focuses or foci. So that is F1 and F2. Then we have to draw a circle of diameter 60, that is the diameter of minor axis. And then we have to measure the distance here, this distance, and plot it on the major axis. So we will get the vertices. Now we can directly draw 2 circles like this. So after that, after this step, everything else is the same as that of the previous question. So after this step we have to draw the tangent and normal to the ellipse at 20 mm from the major axis. So this is the major axis. We have to draw tangent and normal at 20 mm from the major axis. So we have to draw a line initially. So this line is having a distance of 20 mm from the major axis. This line is parallel to the major axis and also having a distance of 20 mm gap between the major axis. So that's what it is mentioned in the question. So this point, the point of intersection between this line and the curve, this point should be considered. This is the required point. So let's say this is P. Okay, now we have to draw 2 lines from the P. Point P is here. So from the point P we have to draw 2 lines to the 2 focus. There are 2 foci on the ellipse. Like this. Okay, now it is not needed to sustain this line, so we can delete. So this is the required point P. Now we have to draw the tangent and normal. For that we have to bisect the angle F1, P, F2. So for bisecting we have to draw an arc which is having the center P. Okay, now at the same radius, if the arc is having this the radius of 15, this arc is having the radius of 15 and the center P, and at the same radius we have to draw another two arcs of 15 mm radius from this point as center and also from this point as center. So the intersection here, the intersection point here, this point is connected. The line is connected from this point to P. So this is considered as the normal. So this line is considered as a normal, which is bisecting the angle F1P F2, and if you draw a line perpendicular to the given normal, this is the normal, and if you draw a line perpendicular to the normal, it will be the tangent. Tangent will only pass through, you know that tangent will only pass through one point of the curve. Okay, so here this will be the normal N, and this is the tangent D. Okay, so this is how we have to draw, we can draw the tangent and normal on the ellipse. So we can draw different kinds of other forms of ellipse in the next session. Thank you.